Sometimes you just got to jump right in and tackle the tough questions. And when it comes to NSX, one of the questions we need answered early on is, what is software-defined networking, or SDN? So in order to get our mind right when it comes to understanding software-defined networking, I want to bring out one of the humblest of network components, and that is the layer 2 switch. When we talk about engaging with a switch, we can actually talk about the way that the switch is a part of the network in three main ways. Those are the management plane, the control plane, and the data plane. So let's first think about that data plane. If I've got a user sitting at their desktop happy as a clam and they connect into the switch in order to, let's say, connect to a local web server. When we describe the process by which a network packet enters the switch and it reads the MAC address and then forwards that frame out to the one and only one port in which that MAC address can be found, which is the web server, and then the web server responds back with that traffic, addressing the MAC address of the desktop, that's data plane traffic. What's control plane traffic? Well, what happens if I have more than one of these lovely devices? Let's say there's another switch. The control plane is going to be used to describe the communication that's going back and forth between these devices in order for those devices to do their job. So in the case of layer 2 switches, control plane traffic might be spanning tree protocol or VLAN trunking protocol or dynamic trunking protocol, protocols that are associated with the switches communicating with each other. And then we get to the management plane. How do we manage this switch and tell it how to function, which protocols to use, and how to work with the rest of the network devices? We're going to do that by either directly connecting in using a serial port, or we're going to connect to that device using a remote protocol such as Secure Shell or HTTPS. But the point is, where is the management done? It's done on this device. If you can't connect to the device itself, you could never create a management instruction. So my friend, with all that behind us, what is software-defined networking? Software-defined networking simply means that we're going to decouple the management plane and control plane elements from the data plane. That means that when we're talking about a device, physical or virtual, that's a part of a software-defined networking environment, the job of that device is to move packets. But what that device is no longer responsible for is management. You don't manage the device on the device, you're going to manage the device someplace else. And that means that the management plane instructions on how that device should behave, or the control plane operations to determine how that device communicates with other devices on the network, is not being defined locally. Instead, there's something else. There's going to be another device or another virtual machine that is going to provide the instructions to the actual switching component in order for it to do its job. So we're going to be looking from time to time at this diagram. I really love this diagram because it breaks down the way that we work with our NSX environment in terms of software-defined networking and in terms of these different planes. So you'll see at the data plane, we have devices. We're going to have routers and switches and load balancers and firewalls that are distributed across all the ESXi hosts that we have. And we can have those devices as edge devices too, which basically just means VMs. But we've got devices. You know what those devices are going to do? They're going to move packets. You know what they're not going to do? Control and management plane operations, because those are being handled by other elements. We'll find that our distributed routers are managed by a logical control VM. And so when we have protocols like OSPF, OSPF doesn't have to communicate with each and every ESXi host with its distributed router element. Instead, it's going to work with a centralized control VM. Likewise, when it comes to management, we don't do our management on each and every one of these devices. That would be crazy. Instead, we're going to have an NSX manager, which is going to integrate into our vCenter server that will then push those instructions to all those devices as needed. So software-defined networking is just this element of decoupling, and NSX certainly is an example of software-defined networking. Now, software-defined networking is not an end unto itself in the case of NSX, but I want you to think about this. Because we've done this decoupling of the management and control plane, I can roll out another router, and you know what? Because it's just another router, it can instantly learn how it's supposed to behave from the management and control elements without having any manual operations have to be performed on it. NSX is an implementation of software-defined networking that is going to allow us to rapidly deploy virtual networks that are going to work in tandem with our virtual machines. We're going to build out these VMs And we want them to be able to communicate with each other in our physical network, and we don't want to have to go through the pain of reconfiguring a physical network every time that happens. So NSX is there to pair up with ESXi, with our vSphere deployment, in order to smooth out that process. And the way that it does that is through software-defined networking. I hope this has been informative for you, and I'd like to thank you for viewing.